Hello, this is Brian Ryo with the final for the graphics class. Uh, the final scene that I was trying to implement was an alien world that is very rocky, with our protagonist being this alien sending up a distress signal so that the mothership can come and find him. The mothership is right here. Um, in general, that was the scene that I was trying to get, but I should briefly mention the things that I created to make the scene possible. The very first one is the skybox, as you can see. The skybox is right there. The terrain is also built off of the height map. Um, the pre-made models include the cube as well as this pyramid. I thought it would be funny because everyone says that the aliens built the pyramids, so I added that into the scene. But I also added some of these volcanoes. These are loaded from file. I created these models to try and just show off that this is a very dangerous world and location. I also loaded the frigate from file. And in the center, I just have this sphere working as a distress beacon, shining lights around. And the frigate itself is also shining a light, signaling that it's found our little alien. I wasn't able to load in an alien texture, so I just put the alien's face on this cube, just for simplicity and to illustrate the point. There's also one more light out here because I wanted basically the entire scene to look like it was nighttime, but that didn't really work because of the skybox, and I couldn't find a darker skybox. Also going in mentioning the fog effects. These two objects, being the frigate and the pyramid, they fade out into blue because I thought it would be a better effect that they fade into the color of the sky rather than the ground. The pyramid or the volcanoes fade into brown, the same color as these as the terrain, so that way they just blend in. The cube also fades into brown, so that way at the proper positions you cannot see it. The only thing not affected by the fog is the distress beacon, mainly because I thought it would make sense that the distress beacon is able to be seen from afar and always clear. But again, the user is able to define the color and everything on the fog, including the distance and to how far things will fade out. I'll demonstrate that in code, and just the lights in general, the lights spinning around, the light on the ground, illustrating that there are multiple lights on the scene, as well as the directional light, which covers the entire scene in general. So I have the 1, the 2, and the 3 being the sunset right here in the back, this chocolatey color. But other than that, I hope all the things that I imported make sense to the scene. Again, the volcanoes and everything else, making it look like an alien world. Going into the actual code, I tried to streamline as much of the DirectX CPP as possible. So right here, I defined the user to load the two shaders. The shader texture, which does not implement light, that is for the skybox, mainly because it doesn't make sense for a light to be spinning around and the skybox to be reflecting that light and having a specular on the sky. The skybox should, in general, just not be affected by anything and be the proper color when needed. The texture and light shader is basically a giant shader HLSL file that takes into consideration virtually everything. It takes into consideration all the light sources, the color of the object if nothing is on it, or sorry, the color of the light, as well as the texture of the specific object. So that way I just use one single shader to implement all the colors, all the lights, and all the textures. The textures are loaded here. You can see all the colors and everything. The models, as you can see, I load these models from file. All of them are Zool files. The ground is a model created from the terrain using this terrain map scaled to size 10 with a repeated U and V of 10. These values do not have to be provided. They are there just for my scene because I wanted it to be a specific size. And the skybox as well, just to give an example, it does not need those specific values to actually call the skybox. But you give it a value and it increases the world to whatever value you provide it. But in general, the ground and the sky are built to scale, but you are able to pass in those parameters to give in the size of the skybox and the ground. Apart from that, we create game objects after we load in our models. We load in our first is our skybox. We set it to the world since it's not going to be moving around. The ground, we give it its information. It also could be set, but I was planning on having the ground move a little bit, kind of like an earthquake, so I did not automatically set all its information. Again, all these objects are not set already because of the idea that I plan on having them move, but in general I create graphics objects using the texture and light class, which uses the multiple light shader. I initialize all the world matrices to place all these objects into the world, and since two of my lights do not move, that being the sunset light and the spaceship's fuchsia color light, I set those automatically, so that way I don't have to call them on every update. This is our moving light. It moves around the sphere, showing that it's a distress beacon. And again, the very first thing we do is we make sure we send the information saying that the third light has been moved. We send our eye position. We get it from the camera once and send them down the pike. All the other things, we set our texture to context, and then we set our camera matrices. We send in our view and our projection, so that way we can place that object relative to the camera, and then we render that thing out. Again, since the skybox doesn't implement fog, we do not include it, but going into the terrain, which does, we do much of the same information, but this time we send our fog parameters. We send our near distance and our far distance, as well as the color of the fog. And each individual object, as you can see, can have its own parameters. So that way, there's only a singular fog parameter, but since we're changing them constantly, we are able to change the fog all at once and change it for the specific object. So fog doesn't in general have to be just a singular color that affects everything. It can just be fog in the distance as things fade out, as you saw in my demo. But the ground also has its world and matrices, its set world and material, so that way we can set that object in our world, as well as set its color for its reflection. We can also do the same thing for the pyramid. It also has different values for fog. We can also do those values for the ship. This ship's fog is a different color, as well as its ambient color, gray. The volcanoes as well. The important thing to note about the volcano is that since all the volcanoes are the exact same object, in order to save memory, we don't have to create 3 individual volcanoes. We can just swap out the world matrices uh, and just render it multiple times. So that way we just say this is the first one at this world, render it, second one render it, third one render it. And the very last one, the box, which is our alien, this is its information, the ball being the distress beacon, as you saw. It has its own parameters and everything else. Apart from that, at the very end, we make sure that all our shaders, all our textures, all our models, and all our graphics objects are deleted. Since we didn't create any additional buffers, we don't have to release anything else, and that should cover everything for that. The first thing that I will go over, I guess, are our pre-made models. So we'll go into the model class specifically. This is very much what you have provided us. However, I have included the unit box, all this other information for our basic ones, our default skybox, and in another version of model, we also include the terrain. Here's our other skybox when it's set to its size. And we also have terrain here when we set its size, repeated U and repeated V. These again also have default parameters just to so that way they're always set to scale. Moving on, we'll go into our model tools just to briefly show all our things. So we have our unit box with repeated textures. We calculate its normals. We have its UV values, its positional values. Skybox works the same way, except we invert our faces, so that way we only get the inside and not the outside of the box. When we create our terrain, we load from file. We also generate its height, given its whiteness on a particular pixel. Our X and Y positions are dependent on whatever our size we pass in. If not, it's just made to scale, which is a 1 by 1 by 1, which in general is almost useless since everything else is to that scale. But it can be increased and it will stay at that scale. We have our repeated textures. Again, they all have normals, their UV values. The pyramid is also here with its normal and UV values, etc. The model, or the skybox, as we mentioned, basically we implemented the skybox into the model tools in here. I originally did have it as its own class, but I thought it would be simpler if it was part of the model tools, since in general it is a model and it is something that is internal to our model system in general. Or that's the way I wanted to proceed with that idea. It could be its own individual class and then just return basically a model pointer. But I thought it was simple for it to just go through model, and it's easier to call on the user when they decide to do new model and then the type of model being what they desire. But as I mentioned before, the skybox goes through this, and the terrain also goes through the model. And when we put everything together into the graphics object, that's how those things are rendered to the screen. We give it its texture for both of those things, and it's just generated. So I mentioned those things. I'll also mention the shader classes. Mostly I'll mention the very first one, being that giant Uber shader that I mentioned, which is the multiple color lights plus texture shader that I created. In general, it has its default layout of its position, its texture coordinates being its UV, as well as its normals. In general, it has all these buffers as well as a fog buffer, and the fog buffer is for the user to define their fog settings, as I mentioned before. I'll go into that in a bit. Since I did create that fog buffer, I added this fog buffer. I have to release that fog buffer once I'm done with it. Going into the lights, I have a singular directional light for my multi light shader, but I do have multiple point lights and spotlights. So the user gives in a light number that's available in the array, and what ends up happening is the array sets all its values for the ambient, diffuse, specular, and everything else for both types. And after that information is put into our buffer inside the array, which is in our buffer, at the very end, we will send all that information with each one of these spotlight data within our array, and we'll send them to our GPU. The other thing that we send is our world data, and we also send our fog parameter buffer right here. So when we send this information to the GPU, it will get it as another buffer. The very last thing, as I mentioned, is the fog parameters. We have our start range, our end range, and our color. That's put in, and I do mention that the default for the color is midnight blue because that's the original background of the window. But again, the user is able to implement their own color, and that information is sent along into the GPU. Into this actual HLSL file, much of the information is the exact same as the single color light file, with the big difference that we have to include our buffer. So our buffer is right here in register 3, fog start, fog range, and fog color. We also have to take into consideration, because we have multiple lights, our point light 1, our spotlight 1, our point light 2, and our spotlight 2, as well as our original point and spotlights. So after all the light information has been calculated, we get our color at the very end of all of our lights. We multiply that by the color of the pixel at that same position, and then we do our linear interpolation of the fog, and we add that to our light color. At the very end, the color that is returned for that specific pixel is influenced by all the lights, by the texture on that object, and by the fog in the relative area. So that should cover my shader and associated HLSL. Let's see. Shaders are expected to correctly work with the perspective of the camera. I've mentioned that these are Phong pixel shaders with multiple lights, as I've mentioned. The fog system that's given to the parameters, I also mentioned that that is a buffer. Since the shaders control so many things, we don't want the user to set every one of them. Again, as I said, there are a lot of default parameters, so that way the user isn't affected to provide everything. If the user does want no fog visible, they would just increase the value of the fog to 10 or to some arbitrarily high number. But by default, there is a moderate fog that's applied. And if they do not want it, they can remove it. Graphics objects, as I mentioned before, everything in the scene is a graphics object, and I'll go into the file. So our default graphics object, texture and light, uses the multicolor light plus texture shader that I mentioned, and it has its default where if the user does not give the texture number, or our default for the graphics object texture and light is that there can be up to four meshes in any given model. There can be four textures for every mesh, and there can only be four meshes in a graphics object. Sorry, that took a little bit longer than expected. Since we do have a number 0 through 3 of meshes, we have to place the given texture into its appropriate mesh. So if the user only has a single model and texture that they're implementing, then we just place that inside our graphics object. Apart from that, we set textures for every single mesh, so long as that mesh is of a reasonable value. The very next thing is this is simply a pass-through for our shader, where we give the light parameters, we give our point light parameters and our spotlight parameters when needed. And we also set our camera matrices and our light parameters, our world color, our world and material parameters, so that way when we render, we send all that information all at once, and the user only has to call render. If there are more models, we send that model material color to each individual object, and then at the very end we just render the entire model. But that should cover our graphics object, and as I mentioned, that's how all of these objects are working, with at the very end calling render, and again changing the fog parameters when needed. As I've shown, I've tried to streamline the DirectX app, tried to make it a little bit more clear, so shaders, textures, models, setting world matrices, light positions, and tried to minimize as much as I possibly could, considering that there are a couple models in here. And at the very end, I try to make sure that I delete everything for the DirectX app. I think in general I've covered everything on the checklist. I have made other models for other people, so somewhere in the common folder there is a star, a comet, some solar panels, which I believe Spencer said he was going to use. So I have implemented those and seen them work, but in my specific scene they don't necessarily work with the aesthetic. Apart from that, again, I think I've covered everything. Thank you, and goodbye.